So now let's take a look at example number 2, where we're going to actually try to prove that the limit of this function actually is 5, using only the definition of the limit. Now, in order to do this, again, we're going to have to do more than what we did in the last example, because in the last example, we only showed that there was a specific value of epsilon where we could find a range of x values to make the associated y's. And we saw at the end of the last video that we have to make sure that we don't just check one epsilon value, but every epsilon value. So let's talk about how in the world we're going to do this. First off, we're going to oftentimes try to just do some scratch work to try to figure out what our delta is, and then we'll write up our solution after we have delta in mind. So for our general proofs like this again, we're going to have to work with kind of like a mystery epsilon. We'll kind of pretend that someone just hasn't told us epsilon yet. So let's go ahead and quickly think about what it is that we want, and I'll label this portion of our work here as really just scratch work. Okay, so here's what we want. We want to show that if the absolute value of x minus 3 is less than delta, if we can pick a value of delta that makes that work, or we want to pick a value of delta so that when this works, then it will be the case that our 2x minus 1 minus 5 will be less than epsilon. So again, just keep in mind that this is like that value 2 in the last problem. We're just going to keep it general this time. All right, now let's take a look and see what we actually have here. We're going to start by investigating the same stuff that we did before. So I'll say we note that this absolute value of 2x minus 1 minus 5, we know that that's going to be equal to 2x minus 6 in the absolute value bars. We know that we can rewrite that as 2 times the quantity of x minus 3 in there, and we saw in the last video how we could rewrite that as 2 times the absolute value of x minus 3. And now, wait, we still know this following fact. I know that 2 times x minus 3 should be able to be compared to a quantity of 2 times mystery value delta. And I know this because delta is going to be a value that is bigger than the absolute value of x minus 3. So just pretend that both of these are like numbers. Here I have 2 times small number, and here I have 2 times big number. That's just based off this inequality. And so therefore I know that this side would have to be bigger. So far what I've established is that my blue stuff, my f of x minus L in the absolute value bars, is so far going to be less than 2 times delta. But I don't want it to be less than 2 times delta. Remember, I want it to be less than epsilon. So if I could pick delta to be anything in the world that I want, I might go ahead and pick the following. I might say, notice that if delta is simply equal to whatever epsilon we were originally given divided by 2, then notice this would imply that 2 times delta is identical to epsilon, right? Like you could multiply the 2 over to the other side. 2 delta would be equal to epsilon. And then from the line above, we would have that the absolute value of 2, oops, miswrote that, but this would be the absolute value of 2x minus 1 minus 5 would simplify all the way down to actually be 2 times the absolute value of x minus 3, which is less than 2 delta, but 2 delta is identical to epsilon. So if someone comes to me with a value of epsilon, maybe say like a value of 2, I now have a formula for how I'm going to select the value of delta. I'm going to go ahead and say, if you tell me epsilon is 2, I'm going to plug 2 into this formula, and I'm going to tell you that delta should be, look, 1. That's what would make this work. So I've kind of found what I need. In this case, my delta apparently depends on epsilon. And that's a very common thing. We'll see that a lot. So with this in mind, I can now go ahead and actually write up like my full solution to this question. I can word it something like this. Suppose epsilon is some positive real number, right? Someone gives me an epsilon. Okay, let's suppose that. Then I'm going to say, let delta be equal to whatever number I was just given, chopped in half. Then we can see that if the absolute value of x minus 3 is less than delta, then the absolute value of 2x minus 1 minus 5 is going to be, and I'm going to write out all of the work that I need here. I know this is going to turn into 2x minus 6. I know it's going to turn into absolute value of 2 times x minus 3. I know I can rewrite that as 2 times x minus 3. Again, I'm just kind of recopying a lot of my scratch work down here. I know this turns into 2 times delta, and then of course I know that 2 times delta ends up the same as epsilon. And so I actually have it. I have that if there's an x inside the red interval, I can guarantee you by selecting this value for delta that I'm going to get my y value inside the blue interval. And so I can reach the conclusion, thus we can say that the limit as x approaches 3 of 2x minus 5, or sorry, 2x minus 1 is actually equal to 5. We have a proof, and usually we culminate our proofs with nice little squares in mathematics. You don't have to write that. It's just kind of a fun thing. It's what a mathematician would do if they were ending an argument. They put a little square at the end. It's kind of like a little drop the mic moment of mathematics where you get to feel really good about, hey, this is my argument, and now it is complete. Now, like I said at the start of this section, these problems and concepts are not easy. So if you're watching these videos right now and you're thinking to yourself, what the heck just happened? You're par for the course right now. Most people watching this are probably very confused. So don't be afraid to rewatch these videos or to email me with questions or to stop by office hours and we can talk about these concepts in more detail.